Right, well, I'm going to try and explain to you what relative mass means, and it's an easy thing, really, to be honest, which is nice in chemistry GCSE. This is a nice simple thing. So I'm going to explain what mass is and then say why it's called relative mass. So we've got a neutron then, and some strokey beard science people had a look at an atom and they said, okay, the middle of the atom has got neutrons and protons in it. And we're going to say, after looking at the mass of this neutron, that it has a mass of 1. Now these scientists, they can't say whether they were it wasn't 1 milligram, nanogram, gram, elephant, kilogram, feather. They just decided it was 1 because it was simple. Now relative to this, that means compared to this, they looked at the proton and they said, okay, the proton it has the mass as the same. It's the same mass as the neutron. So if I compare it to the neutron, it also has a mass of 1. Obviously scientists speak like that. So these aren't 1 anything, there's no units, they're just compared to each other. If we say neutron is 1, then a proton is 1. Now in reality, the mass of an atom of carbon 12 on the periodic table, is this huge great number here, which is far too long for me to go on about. And here, a mass of a hydrogen atom is this, where that's a shortened version of this thing here. So they're not very simple numbers to use, and because we like to make things simple, this is where we've come up with this relative mass. So what they've said is, right, here is hydrogen, this is how much the mass of hydrogen atom is, and we shall call that 1. We shall call hydrogen, the mass number of hydrogen, 1. Although it is this in grams. We should just say it was 1. And then we will compare everything else, okay? We will compare things to this and this. In reality, they started with carbon, but let's go with hydrogen. So we will say this is 1. Now carbon, if I work out the mass of carbon, I can say, ooh, well, it's 12 times heavier than this one. It's still a very teeny number in grams. So we can say, oh, it's number 12. It is 12 times heavier than this one. If I weigh magnesium, or I work out the mass of magnesium, I can say, oh, it's 2 times heavier than carbon. 2 times heavier. Carbon is 12, so magnesium is 24. Okay? So there was born the relative mass, and they are the top numbers on the periodic table. You might be asked the AR, this is the atomic here. Atom, think about atoms, relative mass of an atom. So they might say, what is the relative atomic mass of nitrogen? And you look at the top number and you say, it's 14. Simple as that. Ooh, easy, nice. Right now, but here, relative formula mass, which is MR, looks like Mr. That's okay as well. Let's have a look. H2O, let's go for H2O. There is my molecule. So we're no longer at the atoms. And we look at the mass. Let's look at the mass of hydrogen. The mass of hydrogen is 1. So it's 1, but there's 2 of them. So add another 1 to it. And then there's an oxygen. So we'll add another one of those to that. And therefore the MR of water is 18. Now it's not 18 anything, it's just 18. Ah. If I did another one, what should I do? CA3. Okay, we have 1 Ca. If I look that up, 1 Ca, that's 40. And then I had 1 carbon. Carbon is 12. And I have 3 oxygens. So 3 oxygens. 16 times 3. Remember, you've got a periodic table in the exam. It's that simple. Let's try and get a calculator up. Come on here, calculator. 16 times 3 equals plus 12 plus 40 equals 100. So the relative formula mass of calcium carbonate is 100. And that's it really. Bob's your uncle.